In this video, I'll be teaching you guys about divergence test. And out of all the tests, this one's the easiest, so that's why this video is probably going to be like 5 minutes long. But, divergence test, what does it tell you? Well, obviously, in the name, it tells you if a series diverges. Diverges if, right? But it cannot tell you if the series converges. Keep that in mind. Divergence test can never tell you if the series converges, and I will repeat that a lot throughout the video so that you don't get that wrong on an exam, because if you put that, you're going to get no credit basically for the problem. Alright, let's first keep this in the corner. Let's first show you what a series looks like. Series is basically, in this case, we're talking about infinite series. Basically, you're going to have a sequence, a of n, represented by the function a of n. And this sequence, and if you don't know what a sequence is, I have a video on that. Link will be down in the description. But this sequence, when added all the values together in the sequence, is called a series. So if you add all the values inside of the sequence, you call it a series. And in this case, we have an infinite series. Therefore, we add up all the numbers inside of the sequence infinitely, up to infinity. So, what is an example of a sequence? I don't know. For those of you that don't know, maybe a sequence could be 1, 2, 3, 4, 5, 6, 7, 8. Right? Anything, any set of numbers that have a pattern basically is a sequence. That's really all. And up into infinity is, well, the pattern here is 1 plus 1 plus 1 plus. Up into infinity, you're going to have, well, infinity. Right? If the numbers keep increasing up to infinity, you're going to have infinity. So, in this case, this series diverges. Well, how do we determine that? Well, if I were to put this into mathematical notation, let's move this to the side. Basically, divergence test states that if the limit as n approaches infinity for your function of your sequence does not equal 0, then your series diverges. So if the function as n approaches infinity, as you approach the infinite term of the sequence, does not equal 0, your function must diverge. I'll do problems on that for you guys so you can actually learn how to use this. But keep in mind. If the limit as n approaches infinity for your function a of n does equal 0, this does not, let's put a red X to make it more dramatic, this does not determine convergence. Convergence. X, X, X. More X's, more X's, more X's. Do not do that. Do not say that converges, or I'll choke you out. Anyways, let's go ahead and move on to some problems and actually show you how to use divergence tests and how to interpret the results from a divergence test. Let's go ahead and determine if this series converges or diverges. So let's go ahead and use divergence test because that's what this video is about. Well, divergence test states, remember, as the limit as n approaches infinity for your function of the sequence, this right here should not equal 0, and if it doesn't equal 0, your series diverges. So let's test that out. Well, if your function n is approaching infinity, you only care about the largest exponent value in the denominator and numerator. So for example, if this was n, if there was a plus n squared here, you would completely ignore this n to the power of 1 here. You don't care about it because n squared has so much of a bigger effect up into infinity that n to the power of 1 does nothing. But in this case, we don't have an n squared. We simply have n to the power of 1, n to the power of 1. And these are the two largest exponent values of your variable n in both the numerator and denominator. Therefore, we ignore everything else. So, as the limit as n approaches infinity for n over n, right? We completely ignore this plus 1. This one, shoo, go away. And because we're approaching infinity, that 1 does absolutely nothing. So now that we have n over n, well, doesn't this just simplify into 1? N over n cancel out with each other. So you just get 1 in the end. Here's the thing. Our limit as our function approaching infinity does not equal 0. Right? A of n did not equal 0. Therefore, this series diverges. Your function equaled 1. I mean, limit equaled 1. Let's divergence test this series. So as the limit as n approaches infinity for your function of the series is as a limit as n approaches infinity for 3 over n. Well, anytime some denominator equals goes on to infinity, it just equals 0. Well, not really 0. You approach 0, let's say. So as n approaches infinity for 3 over n, your function approaches 0. Here's the thing about this. Divergence test, remember, is as the limit as n approaches infinity for a of n. When it does not equal 0, your series diverges, correct? Well, in this case, our function equals 0. So what does this mean? Well, that means that we have to use another test. Your results are inconclusive. Do not say that the series converges based off of this. You need to use other tests in order to find out if the series actually converges or not. Converges, question mark. And I'll spoil a little bit. You're going to use the p-series test, which is also a pretty easy test to use for this. So first, divergence test. As the limit as n approaches infinity for your function of the sequence n squared plus 3 over n squared 5n squared plus 3, sorry, minus n plus 2. Okay. Well, this essentially equals, remember what I said about how you only care about the largest exponents in the denominator and numerator? Well, you only care about n squared, 5n squared here, and n squared here. The rest, grow too slow to care about when you're talking about in terms of infinity. So 5n squared over n squared. Right? All these other ones, shoot, get out of here. They're not the largest exponents. All right, well, what we realize is that these n cancels out, so we just get the constant 5. Well, remember what we said about the divergence test. If you don't get 0, then your function diverges. Series diverges, why do I keep saying function? Then your series diverges. Therefore, this right here diverges. No need to do any further tests. So this right here, if you have some suspicion that your series diverges, do the divergence test, and you don't have to waste your time on the exam. Your answer would just be series diverges. So, as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.